Hello, everybody is talking about AI. We do it also. Today I like to present you our VibeAI software for condition monitoring and predictive maintenance. It can be used also for kind of end-of-line tests. In this presentation I like to talk about the topic regarding the accelerometers and their possibilities which they have. Crucial topic is that each accelerometer have several properties. So for example, if we have a very small accelerometer, then the small accelerometer have relatively high inheritor noise. So accelerometer with 1 or 2 gram weight have inheritor noise of about 3000 micro G. So this kind of accelerometer, it has 100 millivolt per G sensitivity. It's uniaxial. He is in the area of 300 to 400 micro G. So let's assume our phenomena, which must be detected and separated by the AI machine learning, is in the area of 500 micro G, but we use the very lightweight accelerometer with 3000 micro G inheritor noise. So that means the AI model will not be able to separate anything. So in this case, it's called garbage in, garbage out. So next topic is, we have here this uniaxial accelerometer and the movement go in this direction. But we want to detect anomaly somewhere in the structure, let's say anomaly in the gearbox system. So I have here this lever, and here's a kind of extender which pushing this part here in this direction. So even the main movement is in this direction, our phenomena is in this direction. So for this reason, the selection of the accelerometer is a crucial point. So even we have an AI system, we have to know, or we have to evaluate, we have to test which axis is the best one. So for this reason, the 3-axis accelerometer is for such kind of experiments or for such kind of condition monitoring. Also in case if the job is changing during the production or the item is changing, so then it is recommendable to use a 3-axial accelerometer, because you never know in which direction the vibration will be dominant. So I have here now this 3-axis accelerometer connected. It has also 100 millivolt per G sensitivity, and also it is important to pay account to the range input of the DAQ card. So let's assume we have a DAQ card with a range input of 10 volt. 10 volt is equal to 10,000 millivolt. So in worst case, let's say we have a sensor with a sensitivity of 10 millivolt per G. So that means if we compare it with kilograms, that means we have 10,000 kilograms. This would be our measurement range against 10 kilograms in case of 10 millivolt per G sensor. So in this case, you see that on a scale which can measure 10 tones, you can weight a big car. Yeah, but if you want to weight something like item with 10 or 20 kilograms. So the resolution of this scale with a measurement range of 10 ton or 10,000 kilograms will be not sufficient. So for this reason, it is also important to choose the right one DAQ card with the correct range input. So in this case, our plug-in duck light have here a range input of 1000 millivolt. So now I will make here a measurement of the first movement. So means I will record as first a reference file, and then I will make a test file and compare it with the reference file. After that, I will change here this extender position so that the movement will go also in this direction. So then we will see what happened. So the recording time is now 66 seconds for the reference file. So now I continue with the test file. So the machine learning program need a certain part or a certain amount of data for the pattern recognition. So now I change here. Now you can see here the movement of this part. I will change also for this demonstration a little bit the frequency or the speed of the electrical motor. So this is now the simulation that the vibration behavior of the test part and the end-of-line test is now different. So maybe you could hear also, so now the anomaly case is detected, and we have here some several possibilities. In case of anomaly, we just give a signal to the sound card output, which can be used for another PLC systems. So we have here several possibilities to adapt the 3-shot level for the anomaly detector, and we have also additional possibilities to use trigger recording or use a kind of interval recording. So that means all 10 minutes, for example, they will be made a test for 30 seconds. So, and then if everything is within the specified reference file tolerance corridor, so then the information will be green. So if this is outside the information, so if this is leaving the acceptable tolerance corridor, the anomaly will be detected, and then we will get here the anomaly signal also to the sound card output. So altogether, the software is designed for people which don't have deep knowledge about vibration analysis and mathematical backgrounds. So now we see that the signal is different because no movement here. That's why this is now detected as anomaly. So that's all for today. Thank you very much and have a good time.